This is the Pearson Edexcel IGCSE Further Pure Maths Paper 1 from June 2021. The first question is just a discriminant check, so has real roots means the discriminant is greater or equal to 0. So that's b squared minus 4ac, b is this, a is this, c is that. So you put all that information in, you expand out nice and carefully. Remember, this is k plus 5 times k plus 5, so expand all the stuff out. Collect all this together. I've made the k squares positive because that makes it easier to spot a factorization, which is this, and so therefore critical values are minus 25 over 11 and 1. And we want to be less than or equal to 0, so we want to be in between the critical values. This is the smaller one, this is the big one, so we want to be in between that, and that'll be our answer there. Cool. Question 2 then. Cos alpha is this. You can draw a little triangle if you want and just say cos alpha is it's adjacent over hypotenuse. So that's adjacent over hypotenuse in a right angle triangle. Pythagoras says that this length is 4, which we all recognize, I guess. And then, of course, tan alpha is just 4/3. So that would be one way of doing it. Now, that doesn't really work here because angle beta is obtuse, which means you can't just draw a right angle triangle like this because you can't put an obtuse angle in a right angle triangle. But I'm going to do it anyway. So this is sine beta is 1 over 2, opposite over hypotenuse. Get your sides right, come on. And then 2 squared minus 1 squared is going to be root 3 here by Pythagoras, which means tan beta is 1 over root 3. Except this is where this triangle fails because this isn't an obtuse angle. When an angle is between 90 and 180, which is what obtuse is, tan is less than 0, right? It's down here. Between 90 and 180, tan is negative. This actual magnitude of the thing doesn't change, but you just have to put a minus sign in there. So that'll be one way of doing that. Hence show this thing. So this is in the formula book right here. So that's going to be very useful. Tan of alpha plus beta is equal to tan alpha, which is 4/3, plus tan beta, which is minus 1 over root 3, and then 1 minus the two things multiplied together. This makes 4 over 3 root 3 with a little plus sign instead. This is 4 root 3 over 4 over 3 root 3 minus 3 over 3 root 3, and then you can put the two things together. This you can multiply by this instead of having it dividing on the top, just multiply it by all this stuff to make 3 root 3 plus 4 because all the other stuff cancels, and we end up with exactly what they wanted us to get, with m being 4 and n being 3, I guess, and we'll be done. Good, so the gradient, as soon as you see gradient, we think dy by dx, so make this into a product, unless you want to use quotient rule, which you shouldn't because it's garbage, and then do some product rule here. So differentiate this one for just a, leave this one alone, and then leave this one alone and differentiate this one. The minus 1 comes down to make this a minus, becomes a minus 2, and then the derivative of this is just 1, so it just doesn't do anything. And we have this here. The derivative is apparently 18 over 49, so dy by dx is 18 over 49, when x is 2. So sub x is 2 in here and put 18 over 49 in here and just solve this equation. This is 1 over 7. This is 1 over 49, I guess. We can times everything by 49 here to get this, and we'll solve for a as 3, which is what they wanted us to get. Hence, write down an equation. So now we've got y as this thing here. Now, I'm going to start doing all of this in one go because we can spot things quite easily about this, I think. We've got one asymptote at x equals minus 5 because it literally tells us that we can't do that. So x equals minus 5 is an asymptote. That's the one that's parallel to the y-axis. The one parallel to the x-axis is hard as a spot, but it's always just this number, the coefficient of this x, divided by the coefficient of this one. So in this case, just 3. 3 divided by 1 is 3. And the reason you can see that is because if you try making y 3, so imagine this y is a 3, cross multiply, you get 3x plus 15 is 3x minus 3. The 3x is cancelled and you get 15 equals minus 3, which is obviously not okay. So y can't be 3, so you've got an asymptote of y equals 3. Now, the picture is going to have two C-shapes, either here and here, or here and here. Which one is it? Well, to do that, find out which, we can just make x 0, maybe, to start with, to find our y-intercept. So just sub x 0 into here, you get minus 3 over 5, so that's minus 3 over 5 there. And so we've got a C-shape here and a C-shape here. It also wants the coordinate where it touches the x-axis. So just make y equal to 0. So just make y 0 times by x plus 5 goes away. Add 3, divide by 3, get x 1, so it goes through 1, 0 here. And our C-shapes look like this and this, and we're done. Yeah, that's the entire question then, I guess. So good. Question number 4 then. So we have un is this. So if we have n is 1, that makes the first term 2 log 4. And if n is 2, we have the second term 3 log 4. And if n is is 3, then it's going to be 4 log 4, and so on. So the first term a is 2 log 4, and the difference in terms is just 1 log 4 because we're adding log 4 every time. I think we can now use this formula to say the sum of the first n terms is just n over 2 into 2 times this, which is 4 log 4, plus n minus 1 times this thing here. So that's this here. Now, I think I can expand out this n minus 1 to make this. This is 4 plus n minus 1 lots of log 4s, which is just 3 plus n lots of log 4s. But 4 is 2 squared, and this 2 can come out to the front, which will then cancel with this 2, and you'll just get n times 3 plus n into log 2. So that's going to be 3n plus n squared into log 2. But now using the power law backwards, I can put that power up there, and we end up with what they wanted us to get, with a being 3. Good. I don't understand this question at all because you're literally just copying the information they give you in the formula book, replacing x with ax every time you see it in this formula. I have no further explanation other than I don't know what the question is about. Anyway, the coefficient of x is 15, so that means an is 15. And the coefficient of x squared is equal to the coefficient of x cubed. So therefore, all of this stuff here equals all of this stuff. Now, a isn't 0, because if a was 0, this couldn't be the case. So let's divide by a squared to get rid of this and turn this into an a. We can also say n isn't 0 or 1, because n is bigger than 2. So we can cancel all of that with all of that safely, and we end up here. Times everything by 6, you get this. Divide by n minus 2, we get this. We can substitute that result into there. Times by n minus 2, and then this 3n just can times by this n to just make it 3n. And we get this, and then we can, of course, rearrange that for this. And if we have n is 5 over 2, you can put that back in there, and you can find a as 6. Find the coefficient of x cubed, where you just put those two results into here, exactly as they are, the thing in front of x cubed, and you type it in a calculator, and you get this here. Question 6 then, so show this. This is a nice little trick. You don't have to start on the left, and generally you always want to start on the thing that has more stuff in it. So this has more stuff to do. So let's start here, because it's got a couple of terms. So let's start with the right-hand side equals this. Expand this out, alpha times alpha plus beta times beta plus 2 lots of alpha times beta. This minus this is minus 2 of them, and then that refactorizes into this, which is the left-hand side. Good, and then the quadratic equation, this has roots alpha and beta. So therefore, alpha plus beta is minus 7 over 1, because you always use the minus here when you're adding the two roots, and then alpha times beta is just k squared over 1, which is just k squared. Of course, this simplifies to 7k, this simplifies to k squared. Show alpha minus beta as this. We can just use this formula they told us about. So alpha minus beta squared is alpha plus beta squared, which is 7k squared, minus 4 lots of alpha beta, which is 4k squared. This is 49k squared, minus 4k squared is 45k squared. Square roots, the square root of 45 is 3 root 5, because it's 9 times 5, then you root 9 for the 3. Of course, there's a plus minus there, but it's told you alpha is bigger than beta, so therefore alpha minus beta is bigger than 0, and therefore our answer is 3 root 5k, and you just need to explain that for the final mark. Hence, form a quadratic equation with roots alpha plus 1, beta minus 1 in this form here, so therefore alpha plus 1 plus beta minus 1 is minus p over 1, for the same reason this was before. The sum of the roots is minus this over that. Minus p over 1 is just minus p. And the obviously this cancels here. But the product of the roots is q over 1, with no negative required. So now, of course, that just means alpha beta equals minus p. Alpha plus beta is minus p. Alpha plus beta, we already found out, is 7k, so that's good. And this is saying alpha beta minus alpha plus beta minus 1 is equal to q. I can factorize this to be minus brackets alpha minus beta. Alpha minus beta is 3 root 5k, so I'll put that in there. Alpha beta is k squared, so I'll put that in there. And I think now I can just replace these two results into this quadratic here and have my answer. 7 then, so the curve C is this. Use calculus to find stationary points, so dy by dx is 0 as stationary points. So you can use quotient rule here if you want to, but I'm not going to. I'm going to use product rule, obviously, so make this to the power minus 1, and then differentiate this, it just goes away, and you just leave this alone. And then you leave this alone, and you differentiate this. The minus 1 comes down to the front. The derivative of that is 2x, and then this becomes a minus 2, leaving this x alone from product rule. So that's that. Find the stationary points. So we want to set this equal to 0. We can times everything now by x squared plus 4 squared, because that will completely clear out this. There's minus 1 of them here, so if you times it by a squared copy of them, you just get 1 left over, and then 0 times anything is still 0. Of course, this is just x squared plus 4. Minus 2x squared is minus x squared plus 4, which, of course, has solutions. X is plus or minus 2. So to find the stationary points, the coordinates of them, we've got a stationary point when x is 2 and a stationary point when x is minus 2. You just put 2 into here to get a quarter. 2 over 2 squared plus 4 is 2 over 8, which is a quarter. And put minus 2 in there, and you'll just notice you just get the negative version, which is minus a quarter. Good. Show dy by dx is this. So let's write this out again. here it is. And let's differentiate again. So this is just chain rule here. -1 comes down to the front. The derivative of that is 2x, and then you just lower the power down to a -2. Product rule here, so differentiate this one for 4x, leave this one alone, and then leave this one alone, and differentiate this one. The -2 comes down to make this a +4. The derivative of that is 2x again, and then you lower that down to -3. We're trying to write it in this form, so what I'll do is I'll just tidy up these two terms because they actually go together, which is nice, so that's good. And then we can say this is divided by x squared plus 4 all squared, and this is the same but cubed, times this by x squared plus 4 top and bottom to make the denominators match, and now we can put them together. Minus 6x squared plus, sorry, minus 6x cubed plus 8x cubed is 2x cubed, minus 24x on the top there. And you can factorize that to be this. I ran out of space, but you do always want to write down exactly the thing you're trying to get to, which I didn't because I couldn't be bothered. I ran out of space. Anyway, hence, otherwise, determine the nature of these station points. So put x as 2 into here. And if you do, just literally type it into a calculator. It's negative, so therefore it's a maximum. And if you put x as -2 in, you get a positive, and therefore it's a minimum. And that's all you need to do. Question 8 then is a nice question about logs. So we can follow the log law that says we need to multiply these two things together if we're adding logs. So this is log to base a of 6n minus 3. We can now just remove the logs from both sides because we just got log equals log to get this, and then we solve for n. Given that log is that and this, x in terms of p is clearly just p to the power 3 is x. That's how logs work. Here you have to do a bit more work. This 3 can come up to the top here by the power law for logs. And then 2 cubed is 8. And then we can do 2 logs taking away is the inputs dividing. So this is log space p of y over 8 equals 4. Do p to both sides here to get this, times by 8 to get this. And then therefore xy is just 8p cubed times p to the 4 is p to the 7 because you add the powers. And you end up with your xy in terms of p. Good, so this is a very quick question to do. It's asking about equations of normals, so we should immediately be doing dy by dx. That's going to be yet more product rule. So this thing derived is 3x squared minus 2. Leave this one alone, leave this one alone, and then derive this. This is the derivative of this is just -1, so that goes there. We need to put in x is 1 into this to find the gradient at x equals 1. So just put 1 into all of this and type it into a calculator. You get 2. Obviously, then we're looking for the equation of normal. So our gradient, the normal is going to be -1/2. So the negative reciprocal. And then we can just immediately do y minus y1 equals mx minus x1. So y minus -1 equals -1/2 times x minus 1. And actually, that would get you full marks. I think, actually, y plus 1 would definitely get you full marks. But if you want to do a bit more work, you can times by 2 and rearrange a little bit and get your answer in a different way. Couple of questions left to finish then. So they always have the really nice vectors question. OA is 5p, so there's lots to put on this picture here. AB, this one here is 3q, all the way down from there to there. OC is 3/2 OB. Now OB is 5p plus 3q, as we can see. And now OC is 1.5 times that. So therefore this is half of this, right? Because that makes the whole thing 1.5 times just this bit here. So this is just half of this. That's B to C only. And then O to D is 3/5 OA. OA is 5p, so 3/5 of this is 3p. So therefore this bit is 3p, and this bit therefore is 2p because they've got to add up to make 5p. D to C is just clearly going to be -3p plus this plus that. So I'll write that out and I'll collect everything together and I'll get this. DC meets AB, F, so that's the one there. Find O to F. So a few things to do here, but let's first say that D to F can be written as just some amount K of D to C, right? And D to C is what we just wrote down here. So it's some amount K, maybe it's like a 0.6 amount of it, but it's some amount of this entire vector here, that's D to F. And now another way to describe D to F, well, A to B is 3q, so A to F is just some amount of 3q, I'll call it M. And then D to F is clearly 2p plus that's some amount of 3q. But these two things must be the same because they're describing exactly the same vector, D to F. So therefore the p's in them must be the same. So 2 must equal 9/2k, which easily solves for k is 4/9. And actually, I don't need m yet, but I will just say at this point, m we could work out by just saying, well, these q's must be the same as these q's. So 3m must be 9/2k if k is 4/9. The 9's cancel and you just end up with m is 2. 2/3, I think. Did I just get my, yeah, because then you divide by 3, so it's 2/3. So therefore, this here is 2/3 of 3q, which is just 2q. and this is 1q, which will be important later. But for now, k is 4/9. Put that in here. 9's cancel, and so the 2's, you get 2p plus 2q, which I think isn't quite the answer because they want O to f. But O to f is just, of course, 3p plus what we just found d to f to be. So we get this answer here. Like I said, this is 2q and this is q by solving for m, looking at the q's, and then breaking this down into them. But that's 2q and q. And that's going to be really important for the last bit, because apparently there's some point g on O to b such that g to f is parallel to O to a. So g is probably somewhere around here, and this vector is parallel to this one here. Now, this vector here is just 5p, right? So therefore, g to f is just some scale factor of 5p. I'll call that scale factor t. So we're going to have to do this inventing scale factors twice in the same question, which is kind of cool. Anyway, another way to describe g to f would be to say that it's some amount of the vector O to b. It's like some amount of this vector here, n amount of this, because we're just doing this bit here, and then minus this q here, which I found by solving for this m value earlier and breaking it up. So it's some amount of this vector here minus q. But of course, these two things must be equivalent. If I just group this in terms of p's and q's first, I notice there are no q's here. So therefore, this must be 0, 3n minus 1, which means n is a third. And I think that's actually all I need to do, because n was the thing that was breaking up this vector. So therefore, this is a third of this. And so therefore, O to g is 2/3 of this. So O to g is just 2/3 of that, which is 2/3 of 5p plus 3q, which is this here. And we'll be done with that question too. Got one final question, which is that question that is always ruined because this is a calculator paper, and this would actually be good if it weren't, but it's not. So it's just a button pressing exercise, which is amazing. I love it. So we have these formulas in the formula book, and then we have cos 2x is clearly just cos of x plus x, right? We can all agree on that. But cos of x plus x, according to this formula, is cos of x minus sine of x, which is cos squared of x minus sine squared of x. Cos squared is 1 minus sine squared, and then you can expand this out, and you get this here, which is the right-hand side. Good. Next, we want to find out, but before I do that, actually, what I'll say is, clearly, the reason that you were asked to do that is to make this into that. So replacing cos 2x with minus sine 2x, and then adding 2, you get 3 minus sine squared of x, 2 sine squared of x, sorry, I should say. And that's going to make solving for the intersections of this curve and this curve much easier. We can just set this equal to that. It makes it quadratic in sine, which factorizes, you can think of this as 2y squared plus y minus 1 if you want to. It factorizes to this, I think, which means we've got 2 sine x minus 1 equals 0, or sine x plus 1 equals 0. Obviously, sine x equals a half, sine x equals minus 1. If sine of x is a half, do sine inverse, you get pi over 6. It hasn't actually told us whether to work in radians or degrees here, but I thought we're all big boys and girls, so we can work in radians. So pi over 6, and then if you get out the sine graph really quickly, pi over 6 is your principal solution. Then just do pi minus pi over 6 for 5 pi over 6 as this one, and then 2 pi plus another pi over 6 to get a third solution if you want one, because there are 3 solutions here, A, B, and C. Now this one ends up not mattering actually, because the third solution comes from this solution set. If we take away 1 from both sides, sine x equals minus 1 at 3 pi over 2. And then this is the first solution A, this is the second solution B, and this is the third solution C. The fourth solution would be this one up here somewhere, but we're not concerned. When we substitute in pi over 6 into either one of these two curves, we can end up with our y-coordinate, which is this, because sine pi over 6 by design is a half, plus 2 is 2.5, which is 5 over 2. Likewise for B, it's going to be the same thing, because it's exactly the same maths, because that stuff is still a half. And then for C, this is the one where you use this one here, and you put that into here maybe. Sine of 3 pi over 2 is minus 1, again by design, plus 2 is 1, and we'll end up with our 3 coordinates. Now it says use calculus to find the ratio from area of R1 to R2. Now R1, these by the way, sorry, are just the x coordinates of those 3 points there. R1 is just the integral of this curve between here and here, minus the integral of this curve between the same 2 coordinates, so it's just that. We can group these together if we've got the same bounds. 2 minus 2 goes away, which is nice. I've put this back into this form rather than the form we were using earlier, because integrating this is much easier. I mean, if you're integrating something like this here, you just put it back into this anyway. So yeah, I'm using that. These integrate quite nicely. Sine integrates to negative, cos integrates straight to sine. Use this half, obviously, to do, to get rid of this 2 that would be there by differentiation. Put these 2 limits in. Again, calculators ruined this question. It could have been quite interesting, and it's not. You don't even need to do any of this. I was just doing it because I was bored. but you can just type all of that in the calculator. Eventually, you will end up with this, and that's R1. R2 is very similar, but it's the other way around to this stuff here. It's the integral of this one here between 5 pi over 6 and 3 pi over 2 minus the integral of this one here between the same two limits. So it's just the other way around. Again, we can group these together because the limits are the same. The 2's cancel still. We can integrate this in much the same way. The question is again ruined because it's a calculator allowed paper. If you want to, you can do all this work, but you don't have to, and you get to this eventually. And then, of course, the answer is just the ratio of this to that. I don't know why there's so much work here. Clearly, the ratio is 2 to 1 because this is a half of this, but I times by root 3 because I'm an idiot, and then I guess divide times by 4. I don't know. Times by 2. What have I even done there? Times by... Yeah, I've times by 4, haven't I? And then divide by 9. It's obviously 2 to 1. I'll see you next time.